Hello everyone. Welcome back to the channel. In today's video, we are going to dive into how you can optimize your React application, especially when working with functional components. Whether you are dealing with slow performance or just want to make your application more efficient, these optimization techniques are exactly what you need. So to begin with, we'll talk about React.memo, which would help us to prevent re-rendering. So the first optimization technique is definitely React.memo. It is a higher order component that memorizes your functional components and prevents them from re-rendering unless their prop changes. So let's take a look at how it is used. So this is a code example of how you can use React.memo to basically memorize a function. So as you can see, we wrap our components in React.memo, and React will only re-render the component if its props change. This is especially useful when your component renders the same thing for the same input. So next up, avoid inline functions inside your JSX. Inline functions get recreated on every render, which leads to unnecessary re-renders of child component. Instead, define your functional components outside the render method and pass them as reference. So I think this point is pretty clear. Now let's move to the third point, use callbacks and useMemo. So to further optimize performance, we can have two powerful hooks, useCallback and useMemo. UseCallback is used to memorize functions and useMemo is used to memorize computed values. So let's see how these are used. You simply have to import useCallback, and let's say if you are creating a handle click function, you can use it like this. Same goes for useMemo. You can use it to memorize some expensive calculation. Both of these hooks ensure that expensive calculations or functions are only recalculated when their dependencies change, saving processing power and improving performance. Next, we have lazy loading with react.lazy. This allows us to split our app into bundles, loading only what's needed when it's needed. This reduces the initial load time of the application, so it is pretty helpful in reducing the initial loading time. Here is a code example of how you can apply lazy loading in your code base. Now, for large lists, we can use virtualization with libraries like React Window. This ensures that only the items currently visible in the viewport are re-rendered, improving performance. So let's say if we have a huge list and we need to re-render some part of it because the list has started to grow. So instead of re-rendering the entire list, this React window would help us to re-render only the part of list that is visible on the screen. So this is very helpful in optimizing the performance. Here is a code example of how you can implement it in your application. Now let's talk about the context API. When you use React context to pass data through your application, um, you might run into performance issues if the context value changes too often. By default, every time the context value changes, React re-renders all components, consuming the context. To prevent unnecessary re-renders, we can memorize the context value using useMemo hook. So this is a code example of how you can use useMemo hook again. This is quite similar to one of the points we have discussed earlier, but here we have mixed it up with the context API. So in this example, we are using useMemo to ensure the context value is only recalculated when some state changes. If some state does not change, React will avoid unnecessary re-render of the components consuming this context, improving the overall performance of your application. So next, let's talk about optimizing user input handling. In cases like search bar or autocomplete inputs, every keystroke might trigger an expensive operation like an API call or a state update. To prevent this, we can use debounce or throttling to limit how often these functions are called. So here is an example to implement debounce with Lodash. Here we are using Lodash's debounce function to limit how often handle search function is triggered. In this case, it will only trigger after 300 milliseconds have passed without a new keystroke. So this ensures that we aren't making a request on every single keystroke, which could lead to performance issues and unnecessary API calls. So, okay. Now we have covered various optimization techniques. It is important to emphasize profiling and testing. React provides a profiler tab in React DevTools, which allows you to visualize how often components re-render and how long each render takes. So by regularly profiling your application, um, you can identify performance bottlenecks, for example, components that are re-rendering too often or taking too long to render. This helps you to focus on areas that need optimization, ensuring you are spending your time fixing that part of your app that truly needs it. So to conclude everything, um, by using techniques like React.memo, useCallback, useMemo, lazy loading, list virtualization, context optimization, debouncing user input, and profiling with React DevTools, you can significantly improve the performance of your React functional components. The key takeaway here is that performance optimization isn't about implementing all of these strategies at once. Instead, it's about carefully identifying areas where optimization can make the biggest difference and applying these wisely. So, yep, thanks for watching. And if you found this video to be helpful, do give a thumbs up. Bye.